Supernovas are not only awe-inspiring but they also play a critical role in the evolution of the universe. These powerful explosions are responsible for creating the heavy elements that make up everything from the planets to the people around us. They are also the key to understanding the birth and death of stars, and how the universe evolves over time. In this video, we'll take a closer look at the processes that lead to a star's explosive demise, the different types of supernovas that exist, and the far-reaching consequences of these cosmic events. So, buckle up and get ready to journey through the universe's most explosive phenomenon. Supernovas are among the most spectacular and cataclysmic events in the universe. These powerful explosions are triggered by the collapse of massive stars and release an incredible amount of energy, making them some of the brightest and most energetic objects in the sky. But what causes these stellar explosions, and what happens when a star goes supernova? In this essay, we will explore the science behind supernovas and the fascinating role they play in the evolution of the universe. Stars are born from clouds of gas and dust in space, and they spend most of their lives fusing hydrogen into helium in their cores. But as a star's fuel supply runs out, it begins to run out of energy, causing it to contract and heat up. This process triggers the fusion of heavier elements, such as carbon and oxygen, and the star expands into a red giant. For stars with a mass greater than 8 times that of the Sun, the end of their lives is marked by a dramatic explosion known as a supernova. This occurs when the core of the star collapses under the force of gravity, causing the temperature and pressure to rise to extreme levels. As a result, the fusion reactions in the core are suddenly halted, and the star's outer layers are blown away in a massive explosion. There are 2 main types of supernovas, Type 1 and Type 2. Type 1 supernovas occur in binary star systems, where a white dwarf star, which is the remains of a star like the Sun, accretes matter from a companion star until it reaches a critical mass. This triggers a runaway fusion reaction, causing the star to explode. Type 2 supernovas, on the other hand, occur in massive stars that have run out of fuel and collapse under their own gravity. Regardless of the type of supernova, the explosion releases an incredible amount of energy, including heavy elements such as gold, silver, and uranium, which are dispersed into space. These elements form the building blocks of new stars, planets, and even life itself. Supernovas also play a critical role in the evolution of the universe. They are responsible for seeding the universe with heavy elements, which are essential for the formation of rocky planets like Earth. Without supernovas, the universe would be a much simpler and less diverse place. In addition, supernovas are the key to understanding the birth and death of stars, as well as the dynamics of galaxies. By studying the light emitted by supernovas, astronomers can determine the distance to other galaxies and map the expansion of the universe. Supernovas also serve as cosmic laboratories for testing the laws of physics under extreme conditions. In conclusion, supernovas are one of the most fascinating and important phenomena in the universe. These explosive events are the result of the collapse of massive stars, and they play a critical role in the evolution of the cosmos. Through the study of supernovas, we can gain a deeper understanding of the universe and our place within it. The history of supernovas dates back to ancient times when people noticed bright new stars that suddenly appeared in the sky. In fact, the Chinese recorded a supernova event in 185 AD that was visible for 8 months and was brighter than Venus. It wasn't until the invention of the telescope in the 17th century that astronomers were able to study supernovas in more detail. The first recorded supernova in the modern era was SN 1572, which was observed by Danish astronomer Tycho Brahe. He carefully recorded its position and brightness, and his observations helped to disprove the idea that the heavens were unchanging and immutable. In the early 20th century, American astronomer Edwin Hubble used the brightness of supernovas to determine the distances to other galaxies. This led to the discovery that the universe was expanding, which eventually led to the Big Bang theory of the origin of the universe. In the 1930s, theoretical physicist Subrahmanyan Chandrasekhar showed that white dwarf stars, the remains of stars like the Sun, could collapse under their own gravity and trigger a supernova explosion. This work earned him the Nobel Prize in Physics in 1983. The study of supernovas continued to advance with the development of new technologies, such as radio telescopes and space-based observatories. In 1987, astronomers observed the closest supernova event in centuries, SN 1987A, which occurred in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. Today, scientists continue to study supernovas and their role in the evolution of the universe. The study of supernovas has led to new insights into the physics of extreme environments, the formation of heavy elements, and the dynamics of galaxies. They also serve as important tools for measuring the distance to other galaxies and mapping the expansion of the universe. In conclusion, the history of supernovas is a fascinating story of human curiosity, technological innovation, and scientific discovery. From ancient observations to modern space-based observatories, the study of supernovas has helped to shape our understanding of the universe and our place within it. Supernovas have been found in many interesting and creative ways over the years, from ancient sky watchers to modern-day astronomers using the latest technology. In ancient times, people would often notice a new bright star in the sky that was not there before. These new stars were actually supernovas, and they were often viewed as omens of good or bad fortune. For example, in 1006 AD, a supernova was observed in the constellation Lupus, and it was so bright that it could be seen during the day. Many cultures viewed it as a sign of impending doom, while others saw it as a sign of hope. In the 20th century, astronomers began using photographic plates to search for new supernovas. They would take pictures of the same region of the sky at different times and compare them to see if any new stars had appeared. This method was time-consuming, but it led to the discovery of many new supernovas. In the 1990s, astronomers began using automated telescopes to search for supernovas. These telescopes were programmed to take images of the sky at regular intervals and then compare them to look for new sources of light. This allowed astronomers to find supernovas more quickly and efficiently. Today, astronomers use a variety of cutting-edge technologies to study supernovas. For example, they use space-based telescopes like the Hubble Space Telescope and Chandra X-ray Observatory to observe supernovas in detail. They also use large ground-based telescopes like the Keck Observatory and the Very Large Telescope to study supernovas and their host galaxies. In addition, scientists are using advanced computer simulations to model supernova explosions and understand the physics behind them. These simulations allow them to explore the complex processes that occur during a supernova and test different theories about their origins. In conclusion, the search for supernovas has been a fascinating journey that spans thousands of years and involves a wide range of techniques and technologies. From ancient sky watchers to modern-day astronomers, humans have been captivated by these explosive events and continue to use innovative methods to study them today. The formation of supernovas is a dramatic process that occurs in the heart of massive stars. It all starts when a massive star has burned through most of its fuel and can no longer sustain nuclear reactions in its core. This causes the core to collapse under the force of its own gravity, creating a super-dense object called a neutron star. The collapse of the core creates a shockwave that travels outward through the star, causing it to explode in a brilliant display of light and energy. This explosion is what we call a supernova, and it can be so bright that it outshines an entire galaxy for a brief period of time. There are two types of supernovas, Type 1 and Type 2. Type 1 supernovas occur in binary star systems, where a white dwarf star is accreting matter from a companion star. When the white dwarf reaches a critical mass, it undergoes a runaway nuclear reaction that destroys the star and creates a Type 1 supernova. Type 2 supernovas, on the other hand, are the result of the collapse of a massive star's core, as described above. These explosions can be incredibly energetic, producing vast amounts of radiation and ejecting heavy elements like gold and uranium into space. One of the most fascinating aspects of supernova formation is the role they play in the evolution of the universe. When a supernova explodes, it creates shockwaves that can trigger the formation of new stars and even new planets. The heavy elements ejected in a supernova explosion become the building blocks of new stars and planets, including our own. In recent years, scientists have made significant progress in understanding the physics behind supernova formation through advanced computer simulations and observational studies. These studies have allowed us to gain new insights into the complex processes that occur during a supernova and have shed light on some of the biggest mysteries in astrophysics. In conclusion, the formation of supernovas is a fascinating process that occurs in the hearts of massive stars and plays a critical role in the evolution of the universe. While we have made significant progress in understanding how they form, there is still much to learn about these explosive events and the impact they have on the cosmos. Supernovas are some of the most explosive and energetic events in the universe, and they are composed of a variety of fascinating and exotic components. Let's take a closer look at the different components of a supernova. First, there's the shockwave that is created when a massive star's core collapses under the force of gravity. This shockwave is what triggers the explosion of the star, and it can travel through the star at speeds of up to 10,000 kilometers per second. Next, there's the blast wave, which is the outward moving wave of hot gas and debris that is created by the explosion. This wave can expand at speeds of up to 10% the speed of light and can be visible for months or even years after the initial explosion. As the blast wave moves outward, it sweeps up and compresses interstellar material, creating a shock front that emits intense radiation across the electromagnetic spectrum, from radio waves to gamma rays. This radiation can be so intense that it can ionize the gas in the interstellar medium, creating glowing shells of gas around the supernova. Another component of a supernova is the neutron star or black hole that is left behind after the explosion. These incredibly dense objects are the remnants of the collapsed core of the star and can have masses of up to 3 times that of the Sun but be only a few kilometers in diameter. Finally, there are the heavy elements that are created in the supernova explosion. These elements, like gold, platinum, and uranium, are formed in the high-energy environment of the supernova and are ejected into space along with the blast wave. These elements then go on to form the building blocks of new stars and planets. In conclusion, supernovas are complex and dynamic events that are composed of a variety of fascinating components, from shockwaves and blast waves to neutron stars and heavy elements. Through the study of these explosive events, scientists have gained new insights into the workings of the universe and the origins of the elements that make up our world. Supernovas are some of the most explosive events in the universe, and they come in different types depending on their characteristics and the processes that drive their explosion. Let's take a closer look at the 2 main types of supernovas. Type 1 supernovas are the result of a thermonuclear explosion in a white dwarf star, which is a small, dense star that has exhausted its nuclear fuel. In a binary star system, where 2 stars orbit around each other, the white dwarf can accrete matter from its companion star. If enough matter is accumulated, the white dwarf can exceed its Chandrasekhar limit, which is the maximum mass it can support before collapsing under its own gravity. The collapse triggers a runaway thermonuclear reaction that destroys the white dwarf and creates a Type 1 supernova. Type 1 supernovas are characterized by a lack of hydrogen in their spectra and the presence of elements like silicon and calcium. Type 2 supernovas, on the other hand, are the result of the core collapse of a massive star, which is a star that has a mass at least 8 times that of the Sun. These stars have enough mass to burn heavier elements in their cores and produce a series of fusion reactions that generate energy and counterbalance the force of gravity. However, when the core runs out of fuel, the pressure drops, and the core collapses under its own weight, releasing an enormous amount of energy in the process. The energy drives a shockwave that blasts through the star, creating a Type 2 supernova. Type 2 supernovas are characterized by the presence of hydrogen in their spectra and the absence of elements like silicon and calcium. In addition to these 2 main types, there are also subtypes of supernovas, such as Type IB, Type IC, and Type IIB, which are intermediate between Type 1 and Type 2 supernovas and are thought to result from a combination of core collapse and thermonuclear explosions. There are also superluminous supernovas, which are incredibly bright and are thought to be the result of the explosion of extremely massive stars or the collapse of highly magnetized stars. In conclusion, supernovas come in different types depending on their origins and characteristics, from Type 1 supernovas, which result from a thermonuclear explosion in a white dwarf star, to Type 2 supernovas, which result from the core collapse of a massive star. Through the study of these explosive events, scientists have gained new insights into the workings of the universe and the mysteries of its evolution. Supernovas continue to fascinate scientists and researchers, and there are always new discoveries and advances in our understanding of these explosive events. Here are a few examples of some recent research on supernovas. In 2021, a team of astronomers reported the detection of a supernova that appeared to have exploded twice. The supernova, named IPTF-14HLS, was first observed in 2014 and was initially classified as a Type 2P supernova. However, subsequent observations revealed that the supernova did not fade away as expected but instead brightened again in 2015, suggesting that it had exploded twice. The researchers proposed several possible explanations for this unusual behavior, including the possibility that the supernova was powered by the interaction of a massive star with a companion star. Another recent study focused on the detection of neutrinos, which are subatomic particles that are produced in the nuclear reactions that power supernovas. In 2020, researchers reported the detection of 10 neutrinos that were emitted during a Type II supernova that occurred in a nearby galaxy. The detection of these neutrinos, which were detected by the Super Kamiokan Neutrino Observatory in Japan, provided new insights into the processes that occur during supernova explosions and the behavior of the high-density matter that is created in these events. In 2019, a team of astronomers reported the discovery of a Type Ia supernova that appeared to have originated from a white dwarf star that was only about one-fifth the mass of the Sun. This discovery challenged existing models of Type Ia supernovas, which had suggested that they were the result of the explosion of white dwarfs that had reached the Chandrasekhar limit, which is the maximum mass that a white dwarf can support before collapsing. The new observations suggested that Type Ia supernovas may be more diverse than previously thought and that they may be the result of a variety of different mechanisms. These are just a few examples of the latest research on supernovas, and there is no doubt that many more exciting discoveries and breakthroughs are yet to come. Through the continued study of supernovas, scientists hope to gain a better understanding of the universe and the processes that shape it, from the formation of heavy elements to the evolution of galaxies and the cosmos as a whole. Here are some interesting facts about supernovas. Supernovas can briefly outshine entire galaxies, and they can release more energy in a few seconds than the Sun will emit over its entire lifetime. Supernovas can create new elements that are heavier than iron, such as gold, silver, and uranium. These elements are formed in the extreme conditions of the supernova explosion and are then dispersed into space, where they can eventually become incorporated into new stars and planets. Supernovas can occur in binary star systems, where two stars orbit around each other. When one of the stars runs out of fuel and becomes a white dwarf, it can start to pull material from its companion star. If this process causes the white dwarf to exceed the Chandrasekhar limit, it can collapse and trigger a supernova explosion. There are two main types of supernovas, Type I and Type II. Type I supernovas are thought to occur in binary star systems, while Type II supernovas are the result of the core collapse of a massive star. The closest supernova observed in modern times was SN 1987A, which occurred in the Large Magellanic Cloud, a dwarf galaxy located about 168,000 light-years away from Earth. The explosion was visible to the naked eye and was observed by astronomers around the world. In 2017, astronomers detected a supernova that was farther away from Earth than any previously observed. The explosion, known as SN 2017 FAR, occurred in a galaxy located about 9 billion light-years away from Earth. The shockwave from a supernova explosion can trigger the formation of new stars in nearby gas clouds. This is because the shockwave compresses the gas and dust in the cloud, causing it to collapse and form new stars. Supernovas can also have a significant impact on the environment of their host galaxy, by injecting energy and heavy elements into the interstellar medium. This can affect the evolution of the galaxy and its future star formation. These are just a few of the many interesting facts about supernovas. They continue to captivate astronomers and scientists, and there is still much to learn about these explosive events and their role in the universe. Here are some interesting side effects of supernovas. Supernovas can produce strong shock waves that can trigger the formation of new stars in nearby gas clouds. This is because the shock wave compresses the gas and dust in the cloud, causing it to collapse and form new stars. Supernovas can produce cosmic rays, which are high-energy particles that travel through space at near the speed of light. These particles can be dangerous to astronauts and can affect the electronics of spacecraft. The heavy elements produced in supernovas can eventually become incorporated into new stars and planets, including our own solar system. This means that the material that makes up our bodies and the world around us may have originated from a supernova explosion. Supernovas can have a significant impact on the environment of their host galaxy, by injecting energy and heavy elements into the interstellar medium. This can affect the evolution of the galaxy and its future star formation. Supernovas can be used as standard candles to measure distances to other galaxies. This is because Type Ia supernovas have a known luminosity, which allows astronomers to calculate their distance based on their observed brightness. Supernovas can also be used to study the expansion of the universe. By measuring the redshift of light from supernovas, astronomers can determine how fast the universe is expanding and how it has changed over time. These are just a few of the many interesting side effects of supernovas. They continue to fascinate astronomers and scientists, and there is still much to learn about the impact of these explosive events on the universe. As we come to the end of this fascinating video on supernovas, we are reminded of the incredible power and complexity of the universe. These explosive events have shaped the cosmos as we know it, creating new elements and triggering the formation of new stars and planets. Yet, there is still so much we have yet to discover and understand about these powerful cosmic events. As astronomers and scientists continue to study supernovas, we can look forward to uncovering more of the mysteries of the universe and expanding our knowledge of the cosmos.